So the first thing we shall do is to identify probabilistic variables. There are 3 of them. We have the selling price. So selling price there is 4, 5, 6. That is the selling price. Then we have the probabilities. We have 0.3, 0.5. Then we have 0.2. Then we have variable cost. Variable cost, what do we have? We have 2, 3, 4 versus probabilities. Probabilities, we have 0.1, 0.6, 0.3, and then we have sales. Sales is also a probabilistic variable. It's a variable whose values have corresponding probabilities. So we have 5,000, we have 4,000. I can see 5,000 again. That must be a mistake, but let us just deal with it the way it is. If it was to be 5,000, they would have been lumped together with the topmost there, but no problem. So we have probabilities given there, 0.2, 0.5, and then 0.4, 0.4. Fortunately, today, I'm able to mute you from my end very nicely. Great. So, ladies and gentlemen, here we are. So having identified our probabilistic variables like this, we know that the next step will be for us to come and ascertain the cumulative. So the cumulative probabilities, please, you are adding these figures downwards. We have 0.3, 0.8, and then 1.0, 0.1, 0.7, and then we have 1.0. We have 0.2, 0.6, and then we have 1.0. And then we have the random number ranges. So random number ranges, if you recall, the ranges here have to move with a 1 digit. So 1 digit, we have 0 all the way to the upper limit. How do we get the upper limit? To get the upper limit, if you remember, we take the number that is here as if it's a whole number. We take the number that is here as if it's a whole number, and then we subtract 1, yes. So we get 2 like that. So listen to me. The next class will start from number 3. Number 3 all the way to this number, read as if it's a whole number, which is 8, but now minus what? Minus 1. So 8 minus 1 gives us what figure there? 7. From there, we have the next class after 7. Of course, number after 7 will be 8, all the way to 10 minus 1. 10 minus 1 is what? Is 9. 9. So please, should you feel that I'm moving very fast, don't fear raising that with me. Tell me to slow down. But where I feel that you guys are a little bit comfortable, you'll have to allow me to move a bit fast. But if I'm again very fast, the essence here is not to move fast to the extent that I leave you behind. Now you need to signal, tell me, Mwalimu, hey, slow down a little bit. Now the next class, next variable is here. Of course, it's 1 digit. So it will be 0 to 1 minus 1 gives me 0 or just 0. Next number is 1 all the way to 6. The next number will be 7 all the way to 10 minus 1, which gives me 9. And then now we have 0 all the way to 1. Then we sorry for that. It was an internet issue, but I think your prayers worked. I've never seen it tripping down that way and coming up that fast. Right? Now here we are. So 0 to 1, and then the next one will be 2 all the way to 6 minus 1. 6 minus 1 gives us what somewhere there? 5. And then we have here 6 all the way to 10. 10 minus 1 gives me 9. Ladies and gentlemen, what if we had 2 variables like this, 10, 20, but this time around the probabilities are given like 0.40, 0.60? What if we had something like this? No problem. Look at what I would have done. What I would have done would have been to come and ascertain the cumulative probabilities as usual here, 0.40, 1.00, And then now here we have got 2 digits, 2 decimal places because of 0.40, 2 decimal places. Hence that calls for how many digits? 2. So come and give us what we call the random number ranges. So the random number ranges, what do we have here? Thank you very much, James. So nasema itakuwa 002. You read this as if it's a whole number now, 40. You can now see I'm using 2 digits. So 00 all the way to 40 minus 1, which gives me 39. From there, we have 40 all the way to 100 minus 1, which gives me 90 what here? 99. Right? So you should be able to know how to differentiate. Like here, I'm only making use of 1 digit because of what here? 1 decimal place. Because of 1 decimal place. So are we together up to there? Please use Y for yes. Are we together up to there? Are we together up to there? Are we together up to there? Thank you very much. Thank you very much. Now from there, the last step then will be for us to come and ascertain what we call the simulation worksheet. Simulation worksheet. So very fast, come and give us the simulation worksheet. And then remember, for us, we'll only do how many runs? 2 runs because of just learning. 2 runs. Remember that this will be the column for run number. So we'll have here run 1, run 2. And then for each random number that we have, not random number, but for each variable that we have here, for each factor that we have here, we have to estimate each of these factors using a random number. As in, the first random number that I'll pick will help me pick the selling price. Will help me pick the selling price. The second random number that I pick will help me pick the second factor, which is variable cost. The third number that I pick will help me pick the sales there, will help me pick the sales there. So now these guys are great people. They're great people. They have given me an easy question. What they've done here is to give me an easy question. What they have done here is to give me an easy question. They've given me the random numbers. Like the first one, we have 806, 043. So we have 806, 806, and then we have 043, like that. Now 806 and the 043, I'm pretty much aware that they have given this to me in the form of three digits like that. So they've given me blocks of 3. But you see, it's about me. It's about me. Where are those students? I can't see any student. In the waiting room, I can't see any. I can't see any. After all, I don't even have a waiting room. I don't even have a waiting room. Okay. Well, please help me, do me a favor. Just share the new link. Share the new link to the 2 groups. Share the new link to the 2 groups. Share the new link to the 2 groups. Share the new link to the 2 groups, and let's know that everybody is comfortable. Share the new link into the 2 groups. And thank you very much for raising that. Thank you very much for raising that. Please share this new link onto the 2 groups that we have. Onto the 2 groups that we have. Onto the 2 groups that we have. And let me know that everything is okay. Not yet connecting. Why? I'm able to get 25 runs. It's 25 runs from the question, Fatma. But you see, we can't do 25 runs really when we are revising. In this kind of a class, I'm here just to highlight, right? If I can just demonstrate with the 2 runs, I'm so sure you guys will be okay. You can do the other runs, 2 for purpose of learning. So these students, the new no, they haven't yet come in because I can see we are still 40. What is not happening? What is not happening? What's not happening? What's not happening? No, share that link there. And I've tested and seen it is working. Okay, thank you very much. So here we are. So there are 3, but you see, given that I decided to work with 1 digit, so I'll be picking 1 at a time. So 1 at a time. So we start with 8, then we have a 0, then we have got a 6. I've decided to pick the random numbers first and just putting them up there. And then run 2, we have here 0, 43, 3 there, like that. So we're asking ourselves a what if analysis question. What if in the selling price the random number is 8? What if the random number is 8? 8 is here. This gives me what selling price? It gives me a selling price of 6. What if the random number is 0 for variable cost? 0 for variable cost is here. This gives me 2. What if the random number is 6 for sales? 6 for sales, that gives me 5,000 units. Remember, these are units. These are units. Of course, this exam at the end of the day will ask you to get the total contribution. So how do we get the total contribution? If you remember, to get total contribution, to get sorry again for that. To get total contribution, what are we doing? We normally take price minus variable cost multiplied by number of who? Number of units. Price minus variable cost multiplied by number of units. So the selling price is 6 minus variable cost here is 2 multiplied by number of units here for this run, they're 5,000. Could you kindly give me the total contribution here for run number 1? Kindly give me the total contribution for run number 1. Give me the total contribution for run number 1. So Lillian tells me it is 20,000 Kenya shillings. 20,000 Kenya shillings, right? So then could you kindly give me the total contribution for run number 2? Give me the total contribution for run number 2. The first thing you've got to do is to estimate the metrics here. And don't forget that quantity is our X. Don't forget quantity is our X, selling price is our P, variable cost is our V, like that. Variable cost is our V, like that. So please give me the total contribution for run number 2, and then I would want to know whether we are comfortable, all of us. All of us should be comfortable, really. Great. So are we okay with this one? Okay. Thank you. Okay. So Becky is asking, Mwalimu, for the random numbers, why do we pick single digits instead of the 3, like 8 or 6 for round number 1? Instead of the singles, No range could fit. We have already used them. Now, remember, like now here, if I was to pick the 8 or 6 the way it is, 8 or 6, and then we put this 8 or 6 here, 8 or 6 here, do we have any 8 or 6? Then automatically that number will be outside the range. And that is why we are told. Actually, if you get, if you can even Google later on and look for random number tables. Random number tables, these guys will give you like so many numbers in a particular row as a block, say like 7, 10, another block with another whatever size. It's upon you to know that if you have one digit here, if you've got what here, we have got one digit there, then automatically for the random number ranges, we shall be partitioning into 1, 1, 1. Listen, if for example, we have 8 or 6, and then we have 9, 62, and then for instance, these one here probabilities were 0.30, meaning that these one here would have been two digits, then my partition would have been like this, 80, 69, 62, etc. So the first one I would have used 80 here. The second one I would have used 69 there. The third one I would have used 62 there. And then remember, we don't simulate going downwards. The runs are normally independent. We normally simulate row-wise until you finish row number 1. That's when you go to row number 2. So are we together now up to there? Are we together up to there? Are we together up to there? Great. Thanks, Becky. Great. Silvanus wants me to start this simulation from scratch, but I happen to be very busy today. Silvanus, because I've recorded this. Yes, the range, yes. 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 Now, of course, at the end of the day, this examiner would want you to come and give us the average. After you've done 25 runs, after finishing, the examiner would want you to come and ascertain the average. How shall we be able to get the average? To get the average, we'll take the total you add, you divide by the number of runs. You divide by the number of what here? Runs. You divide by the number of runs. You divide by the number of runs. Great. Now, ladies and gentlemen, this is mathematics now that comes with a prize. Comes with a prize. This is mathematics for magicians now here, which comes with a prize. Very interesting question. Super Toys Limited manufactures and sells toys. Supercar is one of their popular models. The marketing department has estimated the demand function for the model to be linear. If the price was fixed at $570, then the daily sales of the model would be 400 toys. Whereas if the price was increased to shillings 820, the daily sales would drop to 200 toys. Data from the production department indicates that the incremental cost of producing Q toys of the model is given by that equation, So the question is, have we already taken a snapshot of that question? Have we taken a snapshot of this 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 question? Yes, great, great. So that is question number 1. And then question number 2, of course, I've said it's mathematics that carries a price with it, but very simple at the end of the day. So another question is, can I give you this question as a homework? You try it as a homework. I go to a different question, but you promise that Mwalimu, this question, we shall try it as a homework. As a homework. It has very great concepts of marginal cost. It has got great concepts of break-even analysis and elasticity. And elasticity, is it something you can do later? So long as you promise me you'll be able to do later, I've got no problem with it. Yeah, Brian says yes. Fatma says yes. Deborah says do. Let me count. The do's are how many? The do's are how many? 1, 2, 3. The yeses are, let's do. Let me count. Let me look at it again. Let me look at it again on the steps. Okay. Okay. So then what I'll do, this should be the last one that I'm doing fully. The subsequent ones, I'll only be giving you like a question, and then I give you an answer to the question. So long as I do a few pinpointing here and there, you guys now should be able to go and study and study and study, and of course be able to do what here to move, because moving that way, then we shall not be able to do so much, because I'm so sure, because of fear, not that these students don't understand these things, because of fear. Most of them will keep on telling you, Mwalimu, that one we can't do. But I'm so sure that it's fear that is making them to feel inadequate. But these are pretty forward questions. Like these are pretty forward questions. Like now here, they want us to give them the revenue function. So we know that revenue function, revenue function is derived from the price function. And then they have told us that the price function is linear. The price function is linear. And if it's linear, we know that it should be behaving like this. Price equals A plus BX. Price equals A plus BX. Now, my greatest students, please advise here. Again, I'm asking you for the umpteenth time. How many points do we need for us to be able to define a straight line? Use Q here. I've seen the marginal cost given down there has a Q for quantity. So use Q there. So how many points do we need for us to define a straight line? How many points do we use for us to be able to define a straight line? How many points do we use for us to be able to define a straight line? How many points do we need for us to be able to define 2 points? 2 points, thank you very much. And has this examiner given us the 2 points? Oh yes, he has told us that if the price was fixed at 570, then the quantity here would have been 400 toys. That if the price is fixed at 570, then the quantity sold would have been 400 toys. Very interesting. That is point number 1. And then point number 2, what are they telling us? That should the price go down by just 100 bob, should the price, they're saying here, whereas if the price was increased to 820, the daily sales would drop to 200. So we have 820 and X of 200. So if price is 820, then the quantity, which is not X by the way, quantity has been given to us here as Q, then the quantity here will be 200. Ladies and gentlemen, if that is the case, could you kindly go ahead and form for us the 2 equations? This being a straight liner, we need 2 equations. So the price is 570. The price is 570 equals A plus BQ. Q is 400. So B times 400. So that gives us 400 what here, boy. Equation number 1, equation number 2, using the second point, price is 820 equals A plus 200 BQ. Q is 200. So B 200. So 200. Boy, equation number 2. Now from there, ladies and gentlemen, please go ahead and subtract to be able to eliminate A. Subtract very fast. Please, what is the difference here? What is the difference here? 570 minus 820, that will give us what figure? 570 minus 820, that will give us what figure? That will give us what figure? That will give us what figure? 570 minus 820, that will give us what figure? Minus 250. Thank you very much, Brian. So this disappears. This one I think I know. This one I know. It will be positive 200. Boy. So from there, then, of course, I know that my task is to get boy. So boy will be minus 250 over 200. Minus 250 over 200, which will end up giving us what figure? Somebody, boy. I'm told in this case here by Fatma, not Fatma, Lillian. It's Lillian. So B is negative 1.25. Now, having gotten B, then I should be able to get A from equation 1. I should be able to get A from equation 1. So from equation 1, ladies and gentlemen, what do I have? Equation 1 is here. So we have 570 equals A plus 400B. B is a negative 1.25. So 570 will be equal to A. This multiplied will give me what figure? Somebody. Already they have the figure, James, but just help me for the sake of a student who may not be following because of many reasons like internet. Good to be fair. So minus 500. So please take this to the other side. So the other side will become positive. Therefore, it will be 570 plus 500 equals A. Therefore, A is 1070. Now, ladies and gentlemen, having gotten A and B, the next thing to be done, the next proper thing to do is to come and write for the examiner the equation. You write for the examiner the equation. So go ahead and write for the examiner the equation. So how will our equation look like? So in this case here, we have our P equals A plus BQ. So our price will be equal to A that you have just told me, which is 1070 plus B, which is a minus 1.25 Q, like that. But again, I appreciate the fact that, ladies and gentlemen, that is not the price that they wanted me to get. If you read the question very well, they wanted us to give them the revenue. So then what do I do to be able to get this revenue? What do I do to get this revenue? What do I do to get this revenue? What do I do to get the 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 revenue? Integrate, Neddy, that's a big trial, but you are wrong. You are wrong. Multiply with QES. Remember here, if I'm selling pens like this, what will happen if the price of a pen is 10 bob and I happen to sell, say, 6 of them in a day, then I'll say I've generated revenue of 600 or 60 bob, 10 times the 6. So it is price times quantity, you're right. So in this case here, my revenue will be price times quantity. Fortunately, we have the price here, which is 1070 minus 1.25 Q multiplied by Q, meaning that our R will be 1070 Q minus 1.25 Q squared. Now, by a show of hands, or just by writing yes there, how many students would have gotten this revenue function correctly? How many would have gotten this revenue function correctly? By a show of hands or by Y? James says you would have gotten it correctly. Lillian, yes. HP user, yes. Those are 3 students actually. 3 students would have gotten it. Yes, no. Yes. The number of, or rather the yeses, the way they are coming in very slowly. Winnie, yes. Thank you very much. Great. 50. Now, Kiama, that's a lie. Do you know why I'm saying it's a lie, Kiama? This question, you know, it's either you get everything or you get 0. It can't be 50-50. Even the one who said yes, no. It can't be 50-50. Now, how about Roman 2? Roman 2, they want us to give them the total cost function. Roman 2, they want us to give them the total cost function. Roman 2, they want us to give them the total cost function. So how do I get the total cost? Fortunately, I can see there they have given me the change in cost. The change in cost is 2Q minus 570. Now there is a big mistake that so many students of this semester did. A big mistake indeed. Thank you very much. HP user and James Areba, for sure they would have gotten this correctly. There is a big mistake that these students here did in this semester. Most of them, what they did, waliniambia mwalimu ile kitu mimi niliona nikavalisha miguu. Atikuvalisha miguu, ati sasa ikakuwa ni average cost. Oh yeah. Kuvalisha mguu, atikakuwa ni average cost. Oh yeah. Hapana, hii ni change in cost. This is change in cost. Change in cost, which is the same as what here? Somebody marginal cost. Marginal cost. So in that regard, whatever they have here is our marginal cost, which is 2Q minus 570. And then if you remember very well, marginal costs are the small, minute costs, the minute cost, minute, very small ones. They are fiber costs. Should you want me to give you total cost, what I'll do is to come and integrate, put together these minute costs. We put them together. And if you remember, ladies and gentlemen, if you're told to integrate here ax raised to power n, to integrate this will be equal to ax raised to n plus 1, all over n plus 1. So to integrate, you increase the power by 1, increase the power by 1, and then you divide by the new power. And then please don't forget adding the constant of who? The constant of integration. Don't forget to add the constant of who? The constant of integration. The constant of integration. Constant of integration. So if you're given, for example, here, just as a quick reminder, 5x raised to power 7. And then you're told here to integrate. Integrate is an elongated S. Elongated S for what? Here for summation. You're summing. So if you tell me to integrate this, then this will be 5x raised to a new power. To get the new power, we normally take the old power plus 1. So the old power here is 8, all over 8 plus k, like that. Ladies and gentlemen, here we are. Could you kindly come and integrate this for me? How do you get to integrate? Remember, when I'm integrating, I have got here, I have got this 2q. There is an implied power 1 there. Implied. It's hidden power 1 there. So therefore, to get my total cost, when I'm integrating this, to get my total cost, this one here will be 2q squared over 2. Are you able to see where I got the squared from? Are you able to see how I got the squared? Are you able to see how I got the squared? Yes, I took the implied 1. 1 plus 1 is 2, divided by the new power, which is 2. Minus, of course, this is not differentiation where the power disappears. This is integration where we are putting things together. When you're putting things together, when we see a constant, what we shall do, tunaivalisha the variable, tunaivisha. Kuivisha, kubalisha, Fatma, Kiswahili gani ndio correct, Kiswahili gani ndio correct. So in this case, hapa kama integration, putting things together, this one becomes 570 who? Q. And then of course, don't forget the constant of integration. And of course, this and this will do what here? Will disappear. And then, ladies and gentlemen, please remember that this k is a constant. This k is a constant of integration, is a constant of integration, which will be, in our case here, which will be fixed what here, which will be fixed cost, is a constant of integration that will be our fixed what here, our fixed cost, our fixed cost. It's a constant of integration that will be our fixed cost. That will be our fixed cost. Great, great. So have they given me the fixed cost of this organization? Have they given me the fixed cost of this organization? Have they, how much fixed cost? 1100. Meaning that our total cost then will be q squared minus 570q plus k, which is what here? Which is 1100. K, which is 1100, like that. Great. How many of us would have gotten this correctly? I can see Jesse raising upper hand. Jesse, in the interest of time, given the speed that I am in, I would request if you can just type. If you can type if you have got a good laptop, you type very fast. HP user says, yes, I would have gotten this correctly. Thank you very much, Jesse. This is quite a very useful question. Actually, this is the very best question that I've been ever asked, ever. And I would want to throw, for you to understand its goodness, I would want to throw that ball to my students here. Whether you guys rarely ask questions. You rarely ask questions. I don't know whether this semester I got geniuses, whether I got geniuses in my section 4. Because it's two things. Either you are not able to understand at all, that's why you're not able to ask questions, or you're too bright. You're too bright. But we'll discuss that. We'll discuss that later when we shall organize our get-together. We need a get-together. We need a get-together after your exams, preferably after your results. After your results, you can have a get-together, which you need to decide. We need to decide very early. You can have a breakfast at one of these top hotels, right? It's not very expensive, 2,000 bob. Good breakfast at Kempinski, for example. Ama kama mnapenda raundi, tunaenda Kajiado, tunakula nyama, which is way much cheaper. Way much cheaper. Right? Right? Oh, already, okay. But Fatima, will you come from Mombasa? Will you come from Mombasa? Will you come from Mombasa? Bueno, by the way, ni karibu. Thank you very much. Now, huyu msichana ameuliza swali, na ishaikuwa tested before. Unapatiwa swali namna hii. Hii swali tusiilenge hii swali. Hii swali ya huyu msichana, Jesse aliniambia ni msichana, sijui kama ni Josephine in full. Na to enjoy pia. Sasa ukipatiwa marginal revenue, umepatiwa for example marginal revenue is 10q minus say 5q squared plus say 100, and then somebody tells you to get the total revenue. So we'll have to integrate the minute revenues. We'll have to integrate, we'll have to put together the minute revenues because they're small, fiber to get the total tree, the whole tree. Now you sum all those minute revenues together. So if you integrate this, then you'll end up getting 10q squared over 2 minus 5q raised to power 3, because it's about raising the power over 3. Hapa kuja usiwache ikuwe at constant, ivalishe. Unaivisha, unasema ni 100q, like that. Alafu unakuja unasema plus k. But remember now this k is supposed to be constant. But constant what here? Constant revenue. So the question is, does it exist in business? Is there any situation where you'll be guaranteed of revenue? Where you are told, ladies and gentlemen, that if you sell nothing, you will get 20 bob. Not unless you are a thief. So in this case here, the concept of K does not apply in revenue. Revenue, if you sell 0, like here, if you sell 0, the entire thing disappears. You should be able to get 0 there. So what have we said, Jesse? That in terms of revenue, K is always 0. In terms of revenue, K is always 0. Are we together there? In terms of revenue, K is always 0. Are we together there? Are we together there? In terms of revenue, K is 0. In terms of cost, K is fixed cost. Thank you very much. Great. Great. So, ladies and gentlemen, we have here the total cost function that already we have. Now look at Roman 3. Roman 3, they want us to give them the daily break-even number of what here? Toys. The daily break-even number of toys, the first thing that you need to do for us is to give us the profit equation. When they ask you to get break-even point, please always give us the profit equation. In this particular, this is a functional CVP analysis of functions. So please give us, thank you very much, HP user, Anasema, because they want us to give them break-even. They want us to give them break-even number of toys. The first thing we shall do is to come and ascertain the profit. The profit as per user is revenue minus cost. So the question is, do we have the revenue function? Do we have the revenue function? Do we have the revenue function? Who can remind me? Unfortunately, I rubbed mine. DJ C. I request that now you put your hand down. Otherwise, you will be very tired by the end of this session. You'll be very tired by the end of this session. Put your hand down. Thank you very much. Thank you very much. Thank you very much. Yes. So most sasa niambia ni 1070q minus 1.25q squared. Thank you very much. How about the cost function?
How about the cost function? Cost function. Thanks, James. Thanks, James. So Winnie anasema hajanipatia cost. Winnie hajanipea cost. Hiyo umenipatia ni revenue na cost J abracadabra na cost J itakuwaje? So cost, tushapatiwa cost, wakasema kwamba cost is q squared. Cost is q squared minus 570q plus 1100. And then the thing that they want us to do is to come and plug in these functions here for us to be able to get profit. So profit will be 1070q minus 1.25q squared. Unaweka bracket namna hiyo. Unakuja unasema ukisahau hizo bracket wakati una subtract functions utapata 0. Unakuja unasema minus bracket hapo unasema q squared minus 570q plus 1100 namna. Alafu sasa unakuja abracadabra unafungua bracket. Ukifungua bracket kama hapa nje kuna an implied positive sign. Positive sign is the male sign. And remember male sign, all over you find males. Male ni weaker. Male ni weaker. Lakini ukipata negative hapa nje ya bracket, negative ni female, pili. Lazima kila kitu ibadilike. That reminds me one time, kuna mzee mmoja alikuja kwa matanga fulani. So hizi lazima zibadilike zote. Alikuja kwa matanga fulani, akasema ati ukiona kwenu nyinyi maskini, laumu mama yenu. Ukiona kwenu nyinyi maskini sana, usilaumu mtu yoyote. Kama wewe ni kijana, wewe ni mtoto na kwenu nyinyi maskini, laumu mama yako. Sababu gani unafikiri mzee alikuwa anasema hivyo? Is it because in this case here she is the one who accepted to be married by a poor man? Sababu gani? Because mama ni about changing things in the home. Hata kama ni umaskini namna gani, unaambia watoto wangu amkeni saa 10 usiku msome. Right? Mama ndio mtu wa kuchange. Mzee ni pale, wazee wengi hata sasa ukihesabu kwa darasa hapa. You'll be surprised. Wanaume apart from James, maybe Kiama, Samuel, Felix, wanaume ni wachache sana. Like my section 5 evening, there's a class I teach over 50 people and it's only 5 or 6 who are gentlemen. We shall overcome. The boy child. So kuja hapa, weka bracket namna hiyo nimeshaeleza wanadada hapa wamejua sasa akioa lazima wawe tajiri. You must go there and change things. So 1070 plus 570, that gives us what figure? 1070 plus 570. They're not giving me answers. They're taking time to digest my story. 1570. Wamenipatia tofauti. 1640 na wamenipatia tofauti. Huyu wa 40 ndio ukweli, 1640. So 1640 Q. Hii iko na partner. Ndio iko na partner. Na hii ni minus 1.25 na hii ni minus 1. So unashikanisha zikiwa minus. Kwa hivyo itakuja na kuwa minus 2.25 Q squared. Kuisha maneno. Minus what? Yes, this doesn't have a partner. So minus who? Minus 1100. So that is the profit equation. Thank you very much. Now, ladies and gentlemen, having done that, please always go back to the question and read the question severally. Like now, what they wanted us to do is to find break-even point. Is there anybody who remembers the concept of break-even very well? At break-even, what do we expect? At break-even, what do we expect? At break-even, what do we expect at break-even? At break-even, what do we expect of profitability? At break-even point, profit is 0. That's what you write for the examiner for 1 mark to be given to you. And remember, 1 mark in QA is quite a lot. That 1 mark can make you see places that you've never seen before. Like where? So they're telling me that at break-even point, profit equals 0. Meaning, ladies and gentlemen, that means that my profit equation that I have here of 1640Q minus 2.25Q squared minus 1100 equals 0, equals 0. And then by observation, I'll be able to bear witness with everyone here that this is what we call a quadratic equation. And if it's a quadratic equation, the thing that I'll be expected to remember, thank you very much, HP user, seems to be a good student, although I don't know your name. I should be knowing your name. When you go to Zoom there is a place you'll be able to see how do I change my name. You need to know how to change your name. It's very important. Change your name right for us. You need to know who you are. It's very important. Very important. So he's telling me to come and use the quadratic equation for sure. I know that if AQ squared plus BQ plus C equals 0, then Q will be equal to minus B plus or minus the square root of B squared minus 4AC, everything to be divided by 2A. 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 Let me know whether you guys have been able to write up to there. Yes or no? Let me know whether you guys have been able to write up to there. Thank you very much. So, ladies and gentlemen, please come and compare this with what we have here. AQ squared. A is the number that comes before Q squared. So the number that comes before Q squared is this one. So A is minus 2.25. And then we have B is a number that comes before Q. The number that comes before Q is 1640. And then we have cow. Cow is the constant term. A constant term, please don't bring it on board without the sign. Don't bring it on board without the sign. So our cow will be minus 1100. Our cow will be minus 1100. Now, ladies and gentlemen, the moment you've been able to really get these particular values nicely this way, yours now will be to plug the figures into this Q formula. You plug them there. Very easy indeed. How do I do the plug in? How do I do the plug in? How do I do the plug in? To plug in here is as easy as ABC. As easy as a walk in the park. You know, there is nothing that is easy as walking. It's a leisure walk along the park, any park. So minus B, that gives me minus 1640 plus or minus the square root of this 1640 to be squared. Minus 4 times A. A is here. Minus 2.25 times cow, which is minus 1100, right? And then everything to be divided by 2 times A. A is, which is minus 2.25. Minus 2.25. So then could you kindly do me a favor? First of all, start by getting whatever is under square root. Let your fingers do walking there. Give me, first of all, whatever that is under the square root, as in you say 1640 minus 1640 squared minus 4 times minus 2.25 times minus 1100. Whatever answer you get, I would want you to give me its square root. Whatever answer you get, say square root answer equals, 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 square root answer equals. Abracadabra, these students are not giving me the answer, and the way I've got very nice things for them today. Q equals minus 1640 plus or minus, after square, not even a single student has been able, Jerry has given me a figure of 1636. 1636, 1636, 1636. Sylvanus, don't round off right like that. Don't round off, that's a big rounding off. The least expected to be rounding off is how many decimal places? 2. 2. So it is 36.98. 0.98 all over. What is this? This one here will give me minus 4.2. This one here will give me minus 4.2, minus 4.5. Is that okay? Minus 4.5, minus 4.5. Now, abracadabra, because of these plus and minus signs, which are at the same position, because of the plus and minus signs, which are at the same position, then I have to come and dissect this into two, ask myself, what if I only retain the positive? If I only retain the positive sign, then I'll be having what we call Q1. So Q1 will be minus 1640 plus 1636.98 all over minus 4.5. Please give me an answer for Q1. How do I do it, Mwalimu? It's very easy. You say minus 1640 plus 1636.98 equals first. Equals first. Equals first. Whatever I get, I say divided by minus 4.5. Whatever I get, I say divided by minus 4.5. You can see we're getting different answers for whatever reason, for God's sake. So somebody tells me that the correct answer is supposed to be 728. Is that okay? 728. That is the first answer. When in between here, we have a positive sign. From there, we go straight away to the second one. When we have what here now? A negative. Lilian has already the two figures. Lilian ananiambia mwalimu hata usisumbuke. Usisumbuke. Andika hapa mwalimu Q2. Hapo andika Q2 na hapa change. Weka negative. Na akaniambia kitu mzuri, kitu tamu. Akaniambia kwamba this one here will be minus point what here somebody? Minus. Akaniambia kwamba itakuwa ni minus. Kuna kitu ameniambia ni minus 0.67. Is it minus or plus? I don't know what I saw up there. I don't know. But there is somebody who has told me 0.67. Something 0.67. Koja neke we. Is it 728 or 0.67? You guys have confused me somewhere. I don't know. This Q2 figure is supposed to be what? Q2 figure. Is it the one that is supposed to be 728? The Q2 or 728 is for Q1. So then I'm being told that this one is the one that is 728. And then the other one is the one that is 0.67. Is that okay? Okay, Q2 is the one that is 728. Thank you very much. So if this organization wants to break even, it has to ensure that they produce those number of units. It must ensure that they will produce those number of units. Ensure that they will produce those number of units. Ensure that they will produce those number of units. But you see, at the end of the day, a firm can never break even twice in 2 points. A firm only breaks even once. And of course, the lower is the effective break-even point. So our break-even point here, the effective one, will be 0.67. I don't know whether I'm the one who is confusing this. Which one is better, the lower or the higher? Which break-even point is better? The lower or the higher? Which break-even point is better, the lower or the higher? The lower. I don't know whether I'm confusing because I'm trying to teach you very fast, very many things to the students of mine because I would want them to pass, which also ends up confusing me at the end of the day when he says, I don't know, just like myself. I don't know. What about the other students? What do you know about this break-even point? Should you work with the lower or the higher? Rosie amesema mwalimu nitakufa na wewe ni lower. Sasa ile ukweli ni kwamba lower is always the effective. Just imagine, like at RCM College, like if today, for example, you are to come to RCM College as an investor, alafu naambiwa kuna 2 break-even points. Which break-even points are these? We have 0.67, and then we have, in this case here, 7 to, remember the meaning of a break-even point. The moment you hit a break-even point, you start enjoying fruits in terms of profitability. Now, after this break-even point, you start enjoying. I mean, if there is something I can do to break even at zero, I'll be the happiest man. That I only dish out 1 unit like this and it's able to cover all my expenses. So the lower, the more effective. The lower, the better. Are we in agreement or we are not in agreement regarding that? In agreement or not in agreement? In agreement or not in agreement? You know, like 720 something. Ladies and gentlemen, the higher the break-even point, the higher the investment you would need. The higher the investment you would need. And that is why there are businesses which I can never accept to go into. Because there are businesses that you must sweat for about 5 years without ever getting to recoup your money. So the lower the break-even point, the faster I'll be able to recoup my money. And then I start, in this case, you're doing what you're making, profits like that. Ladies and gentlemen, Winnie, I can see your beautiful hand, very beautiful hand, Winnie. There she has up. Are you able to? Fatma says she got different answers. To help Fatma, negative and positive, to help Fatma, or by mistake, then put that hand down. Don't get too tired. To help Fatma, because I can't write those things here again. Can somebody in this case here take a screenshot of the workings and send them in our group? Send a screenshot of our workings in our group, right? But Fatma, as we get to see those answers, remember when you're getting Q1, first of all, you have to get the numerator value, say equals, numerator value, say equals, and then you divide by the denominator. Because you know that all over is what here is kind of a bracket telling you, first of all, deal with the numerator up there. Deal with the numerator up there. So is there somebody who has been, Fatima says from the square root, it is 1643, not 1636. Fatima anasema atile wakati wa square root, answer inafaa kuwa 1643. Ukweli ama uongo? Ukweli ama uongo? Ukweli ama uongo? Ukweli ama uongo? Ile square root. James anasema ni uongo. Fatima anasema she's confident with the answers. Fatima hizo answers za uongo. Don't be confident of wrong answers wewe Fatima. Angalia hiyo kitu umetuma kwa hiyo page. Right? Now from there, they want us to give them the point of elasticity when the demand is 110 toys. Interpret the economic meaning of your result. The point of elasticity. I would want to see whether we have got any student who is able to remember the point of elasticity formula. Do we have any student who is able to remember the point of elasticity formula? Is there any student who is able to remember the point of elasticity formula? Any student who is able to, ladies and gentlemen, I love the point of elasticity quite a lot. I don't know why I like it. I don't know why I like it, but I really like it. I really like it. So, ladies and gentlemen, this is what I know. That to be able to calculate the point of elasticity, number one, I need the formula. And which, not formula, but really the price function. What I need mostly, the only thing actually that I need here is the price function. So price function, I need the price function. And unfortunately, you guys had given me the price function up there. Was it 1070? The price function, was it 1070 minus 1.25Q? Yes. Thank you very much, HP user. So in this case here, they want me to give them the price elasticity when quantity equals what? Let's see the question. When quantity equals what? When quantity equals, they want me to give them They want me to give them to do something very easy. To give them the point of elasticity when demand is 110 toys. So when demand is 110 toys, you see, when Q is 110, the question is, what will be the price value? So the price here will be 1070 minus 1.25 times the quantity, which is 110. So 1070 minus 1.25 times 110 will be equal to 1070 minus 1.25 times 110. This will be equal to what here, somebody? No, it was not 1070Q. Remember, I'm not talking of revenue. I'm talking of the price function, Moses. I'm talking of the price function, please. Yes, not revenue, price function. When I'm getting a price elasticity, I don't need what here? I do not need the revenue function. So wananiambia itakuwa 932.5. Now, once I have that, it's point elasticity. Once I have that, ladies and gentlemen, then I'll come and remember the formula of point elasticity. Point of elasticity, it's P over Q, and then I know it's dQ over dP. dQ over dP. There is something I forgot. There is something I forgot up here, that you need to differentiate the price function. You differentiate the price function. You differentiate the price function. So could you kindly try differentiating this for me, and then we compare notes. dP over dQ will be equal to who? dP over dQ will be equal to who? dP over dQ will be equal to who? Differentiate the price function. Differentiate the price function. So if you differentiate the price function, oh yeah, this is a constant for differentiation. Constants will always do what here? Will always disappear. Constants will always disappear. And then this one, if I differentiate this, I'll end up getting minus 1.25. This is very important for me. Differentiate the price function. So once I've done that, now I'll be able to come here very, very well. Once I've done this, in this equation, I don't want dP over dQ. I want it the other way around. I don't want this. I want it dQ over dP. Kwa hivyo itakuwa 1 over minus 1.25. Itakuwa 1 over minus 1.25. Because you see in the formula, I want the reciprocal. The reciprocal. Then this EP will be P over Q. The price, fortunately, you guys gave me the price. Price is 932.5. All over Q, which happens to be 110 times this thing, 1 over minus 1.25. So then the EP will end up giving me what figure? The EP will end up giving me what figure? The EP will end up giving us what figure? The EP will end up giving us what figure? The EP will end up giving us what figure? The EP will end up giving us what figure? I'm waiting to be given this figure by my students. So we'll say, so wanasema Njeri anasema ni 6.78. Njeri tulisemaje? Ikiwa hata ni negative hii, we normally only take what here, the magnitude. You forget the negative. Remember, that's what we said. Always, for elasticity, point elasticity, you always forget the negative. And once you've forgotten the negative, ladies and gentlemen, of course, this thing is more than 1. It's more than 1. And if it's more than 1, it means that the product is price elastic. 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 Hiyo kusema ukweli, si utapata kwa mtihani kikuja. So price elastic means that it is price sensitive. If you increase the price a little bit, people will turn away, they'll run away. If you increase the price a little bit, people will run away. There are products that are price insensitive. The ones which are price insensitive are like salt. Trust you me, salt, even if they were to increase the price of salt to 1,000, you still buy salt. Yeah, those are basic needs, commodities. There are things, even if you're told don't take, you'll still want to have them. Remember the other day when they told us that sugar had issues here and there, we tried, like myself, I did like 3-4 days without water sugar. But the few days ukasema taka iko na mercury ndani, later. Because unasikia mwili hapana. Those are what here, basic necessities like that. So now, are we together up to there? 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 Great. Now, ladies and gentlemen, there is something that I would want you to go and read so much. I said that now it will be about you. It will be about you, not about me. If, for example, somebody wants you to apply calculus, but he tells you that a function is quadratic function, he goes ahead to give you a number of points. The question is, do you know how to construct a quadratic function? Do you know how to construct a quadratic function? do you know how to construct? I wish I was the examiner. If I was the examiner, because I know students have already mastered this thing of differentiation. They have mastered this thing of differentiation. They have mastered integration very well. Imagine, you can't confuse them there. But now to bring in some confusion, because as a good examiner, you need to know how to throw students under the bus. Not all of them, some of them. Because again, an exam, you can't have all of them passing, right? So instead of giving them the revenue function, giving them the cost function, just tell them the revenue function is quadratic. And then you give them some number of points. Once you give them that number of points, those number of points, students should be able to recalibrate or recalculate important parameters to be able to get a quadratic function. I don't know whether you guys are getting my point. Is there anybody who has ever seen that kind of a question in an exam? James says yes. Hiyo tuko rada mwalimu. That is what I love. Hiyo mwalimu tuko sawa. Don't even try looking for a question of that nature. Perhaps for them to understand what I'm talking about, James, you can even quote for us the past paper question that has got that concept. I think that way it will be able to help them. Otherwise, you'll get a shock of your life. You go to an exam, a student who has known how to use marginal cost equals marginal revenue to get profit maximizing quantity, right? Yeah, November 2018, question number 2. November 2018, question number 2. November 2018, question number 2, I'm told. I think I also have something. Somewhere. Yes. This question of M. Motuma. The following information relates to M. Motuma, a dealer in standard wooden tables. Right? M. Motuma realized this from 7 tables, that from 9 tables, and 11,300 from 4 tables, all respectively. M. Motuma has approached you for assistance in forecasting future profits. The profit function is believed to be quadratic in nature. So they want you to derive the profit function. They want you, number 2, to give them the profit maximizing output and the maximum profit. So then could you kindly try as much as possible? Of course, I would want to give you this as a homework, but could you kindly just go through this question, try to form the equation like the ones that I have here, just the equations alone, and then I'll be able to guide you what to do next. Right. Thank you.